Good morning, ma'am. I am Manideepa, second BTech from CSC B section. Today I am going to explain about Eulerian graph and Hamilton graph. So, before going to Eulerian graph and Hamilton, first what we have to know what is a graph theory. So, a graph theory is a branch of mathematical that studies graph, which are mathematical structures used to model pairwise relationships between objects. An important aspect of graph theory is understanding different types of graphs, such as Eulerian and Hamiltonian graphs. These concepts have applications in various fields, including computer science, biology, and transportation. So, this is about all the graph theory, and the structure of the graph theory is shown in the figure. So, the graph theory is same as it is the graph which the image will be determined. What is an Eulerian graph? An Eulerian graph is a graph that contains an Eulerian cycle, which is a cycle that visits every edge exactly once. So, if a graph is said that and it is an Eulerian graph, then it must have the even degree of the each vertices. For a graph to be a Eulerian, it must be connected and all its vertices must have even degree. If a degree has exactly two vertices of odd degree, it contains an Eulerian path but not an Eulerian circuit. So, example of an Eulerian graph. A classic example of an Eulerian graph is the Königsberg Bridge problem, where the goal was to cross all 7 bridges without retracing steps. The solution reveals that the graph is not Eulerian since more than 2 vertices have odd degrees. However, a simpler sample example is a square with a diagonal where all vertices have even vertices, thus forming an Eulerian circuit. So, this figure is not an Eulerian graph because more than 2 vertices have the odd degrees, so it is not considered as a Eulerian graph. Next, characteristics of an Eulerian circuits are: Eulerian circuit starts and ends at the same vertex while covering every edge once. All vertices must have even degrees for a graph to have a Eulerian circuit. A connected graph with exactly 2 vertices of odd degree will have an Eulerian path but not a circuit. So, what is an Hamiltonian graph? A Hamiltonian graph is a graph that contains a Hamiltonian circuit, which is a cycle that visits every vertex exactly once. Unlike the Eulerian graphs, there are no specific degree conditions to determine if a graph is a Hamiltonian. The graph determines. So, let us see the example of this. If there exists a walk in the connected graph that visits every vertex of the graph exactly once, except the starting vertex, without repeating the degree of and returns to the starting vertex, then such a walk is called a Hamiltonian circuit. The determination of whether a graph is Hamiltonian is more complex problem and remains NP complete. Example of a Hamiltonian graph. A well-known example of Hamiltonian graph is the complete graph Kn, which contains n vertices and every pair of vertices is connected by an edge. Another example is a 3-dimensional cube, which has a Hamiltonian circuit that visits each vertex exactly once. Hamiltonian graphs are significant in problems like the traveling salesman person, which seeks the shortest route visiting a set of points. Characteristics of an Hamiltonian circuits are: these Hamiltonian circuits do not necessarily require all edges to be traversed, only vertices. So, a Hamiltonian circuit may exist even in graphs when vertices have odd degree. Determining the existence of a Hamiltonian circuit is a challenging problem and it does have a straightforward solution. Comparing Eulerian and Hamiltonian graphs. Eulerian graph focus on edge traversal, while Hamiltonian graph emphasize visiting vertices. A graph can be Eulerian but not Hamiltonian, and vice versa. The two concepts are not mutually inclusive. Both type of graphs have practical applications in routing and optimization problem in computer science. And applications of Eulerian and Hamiltonian graphs. Eulerian paths or circuits are used in network design such as a garbage collection route or postal delivery. Hamiltonian circuits are critical in logistic and scheduling problems like the traveling salesman problem. Both concepts are also applied in circuit design, DNA sequencing, and the layout of microchips. Conclusion: understanding Eulerian and Hamiltonian graphs deepens our knowledge of graph theory and its application. These concepts are essential in solving real-world problems across various disciplines. Further exploration of these graphs can lead to more efficient algorithms and better solution in practical scenarios. So this is all about the concept of Hamiltonian and Eulerian graphs. In this session we will be discussed about the introduction of graph theory and what is an Eulerian graph, example of an Eulerian graph and characteristics, and here what is Hamiltonian graph and example of Hamiltonian graph and characteristics of an Hamiltonian graph. After then we will be comparing both the Eulerian and Hamiltonian graphs. After then we will discuss about applications of Eulerian and Hamiltonian graph and last conclusion. So thank you.